We are today at the Marie Selby Botanical Gardens here in Sarasota, and this is your new gig. In fact, I still have my sticker on. This is your job now. You work here.
Yes. I have the privilege of working here. It's fantastic. So I'm an education manager. My official title now is the manager of visitor engagement. So my job is to engage all you visitors. 99% of all orchids are successfully pollinated based on the structure of their petals, based on the structure of their steeples, based on their coloration and fragrance strategies. It really depends on the type of orchid. One of the really cool strategies that a lot of orchids have is they actually smell like either a female bee or a male bee. So the male bee, if it goes towards a orchid that smells like a female, it'll mate with it or attempt to, and get covered in pollen, realize this is a flower, this isn't a bug, and then we'll leave and then try it again. So the orchids actually have mimicked pheromones of these insects in order to attract pollinators. What makes Selby such a special place is that we are an epiphyte research center. So obviously we're a wonderful botanical garden for you to visit and have food and enjoy just a little urban oasis, but we also are a botanical science institution. So we specialize in epiphytes, and now you know what that is. So what are those big fancy science words? What's an epiphyte?
An epiphyte would be plants that sort of latch on to other plants instead of kind of growing out of the soil for themselves.
Fantastic. Yeah, epiphytes are the big fancy science word for air plants. So it is a classification of plant. It's not a type of plant. There's epiphytic orchids, there's epiphytic ferns, epiphytic lichen and vines, and all of these other types of plants can be epiphytic plants, like all these orchids that grow on structures that do not hurt the structures.
Do they more often manipulate like sex pheromones than they do offer food, which would be like, I would think of a more normal pollinating strategy?
Yeah, so I mean, honestly, one of like the basic strategies for pollination is just having really pretty petals. That's like kind of ground zero. Oh, you look really pretty. That's going to attract a butterfly or a bee. Easy, low-hanging fruit. However, a lot of these pollinators then kind of take it to the next level with just smelling good. Orchids typically attract bees or other types of flies with a good pheromone-like smell. But one of the really cool types of orchids essentially builds a little trap door, and the bee goes in, is forced to pull a U-turn, so get covered in pollen twice before taking off. Now, there's some other really dramatic strategies where orchids actually have pollen hammers, where once the bee or fly lands, part of the flower that pollinates kind of hammers down on it, whacks them with pollen, and then the bee then takes off.
Plants do not have brains. Like, they don't. So it's just wild to think that these plants outsmart insects. Like, orchids are famous for it. Oh my gosh. There's other ones that like mimic male beetle pheromones in order to get angry beetles to like fight them and then thus get pollinated. So the fact that they have outsmarted the behaviors of these animals in order for them to selfishly succeed, I guess, like, it's just really cool to think that an orchid is like villainous, you know, like that they are like, let me manipulate you with my colors and my fragrances and how I am in order for me to be so self-serving. Like, I think it's fascinating that it's like, orchids got it.
I see what you're saying too, and it's a good point, but I also, it's so natural, like even as you talk about it, to personify it in a way that we understand consciousness, to say, I'm going to manipulate you, I have a strategy for this, as opposed to what more likely happened, which is more one happened to have smells that were similar to this, and then, exactly. So, but it's so, we can't tell the story of plants without doing that personification, because there's just no way to fathom that kind of consciousness. We also saw some bamboo as well.
Yeah.
The real thing that was news to me was the idea that because it grows, you know, after you cut the tops off, that it is kind of a sustainable material.
Absolutely.
It's a sustainable kind of wood material that we use for lots of things.
Yeah, these epiphytic plants have some really amazing growing strategies in order to compete against larger plants. Bamboo and grasses in general, one of their competition strategies is just growing so fast that bamboo sets the record for the fastest growing plant in the world.
One of the really cool things about bamboo is that it's a grass. Grasses are one of the most communicative plants in the world. They talk to each other. They have a really special net of roots called rhizomes, and they kind of this big branching network, essentially, where all the roots kind of intermesh, and they talk to each other using a series of like chemical signals. So if one bamboo's over here saying, hey, I'm about to flower, it's probably in your best interest to start flowering too. They can let each other know, essentially.
Theoretically, they're able to grow 35 inches in one day. So wild to think about that these plants have such accelerated growth. And then for that reason, you're right, they're absolutely a sustainable material. A lot of these hardwoods that we use for our homes or furnitures, they take years to grow, and it's just not realistically sustainable to continue to make materials from those plants.
At your yard, back home, when you mow the yard.
My yard.
Your yard, right, because like, you're so domestic, right?
As I do have one.
You're not traveling at all. So as far as grasses go, when you mow the lawn, it regrows, right? If you chop down a tree, what happens to that tree?
Does it not regrow, truly?
It
It would have a hard time, right? Because it's past that stage in its life.
Right. So like if you chop down like a mature tree, like odds are you killed it.
Right.
It's not going to do well.
You can't pull everything just out of the soil anymore. It's too much support.
I mean, there's like a few exceptions, but like odds are if you knock down a plant, you chop down a plant, that's the end of the plant. Too much trauma. Grasses, when you mow your lawn, you're decapitating the yard. However, does it grow back?
Always.
Absolutely.
Okay.
So these grasses grow from the top. They don't really grow from the bottom. So you can see it really clearly in bamboo that they have these like growth rings.
Right.
And I like to think of them almost as like balloon animals that you kind of, and like it grows out and expands using water.
We also talked to the fern specialist here, Dr. Sally Chambers, and she told us all about ferns, and we have fern facts.
For people that may not really be familiar with ferns,
Fernmiliar.
They don't make flowers, right? They reproduce by spores. You can often find these spores located on the underside of a frond. These spores are inside of a really cool structure. They don't need pollinators, they can do all of this on their own. Ferns exhibit desiccation tolerance. What happens is that the ferns will like put their life stage on hold. They kind of go into like a hibernation mode. So they're not metabolizing, they're just chilling until it rains, and then, you know, they're like, oh boom, I can do my photosynthesis and, you know, growth and development and all that again. Spores produce this other life stage. There's some particular species that like never fully grow up out of that life stage. And I call them the Peter Pan ferns. They can also tolerate more like a wider range of like temperatures and things like that.
So it's a survival strategy.
Yeah.
Totally, and it just got stuck.
What else do we do? We also talked about mangroves, too,
Yeah, absolutely.
which was your specialty.
I do love mangroves. I'd say right now mangroves are my favorite plant. Mangroves are, I feel like, the perfect combination of my last job as a marine biologist and now my current job doing botany, so it's a little bit of both, little wet plant.
Mangroves are a marine plant. What makes a mangrove so special is that it is a saltwater plant. So its roots are in salt water. Salt is toxic. They can actually filter the salt out of salt water. So they have this special organ in their root system that allow them to take the salt water, kind of filter the salt out and convert it into usable fresh water, essentially. Those yellow leaves are known as sacrificial leaves, where the mangrove plant pumps all of the salt it just filtered into a handful of leaves. It kills off that leaf for the greater good of the plant itself.
It blows my mind to think about how plants have evolved strategies over millions and millions and billions of years to be able to do now what they do.
Yeah, see, it's an interesting thought because with all things considered, terrestrial plants are actually like a very new thing, which is kind of like, so yes, like millions of years, absolutely. But a lot of the basic like forms of life that we would easily recognize are older than plants.
Mangroves are one of the only plants in the world that walks. Whoa.
Okay.
Oh my gosh, isn't that wild?
How so? So they can move independently. They can lift.
So here's the fun part.
Yeah.
So mangroves live at the tide line, right? What happens twice a day on the tide line?
It's gonna come in and go out.
Exactly. So the neat thing about mangroves is that during high tide, they want the water, but they don't want to drown, right? Their roots are made for the water, not the rest of the tree. So they kind of scoot and adjust their roots and like back up to adjust on the tide line. Then during low tide, they still need water, right? So they can't dry out, so they'll scoot and adjust and adapt to that tidal line.
It's weird to think that we typically classify plants at the bottom of the food chain.
Right, in
Which
terms of
is-
intelligence, for sure.
Or just existing.
Or sometimes at the actual bottom of the food chain.
Literally at the bottom of the food chain. And then we met 4 different species of carnivorous plant that are like arguably not at the bottom of the food chain.
Right, exactly.
Like, I mean, granted, their first choice is to photosynthesize. Like, that's their goal. Like, so those little snap trap leaves on a Venus flytrap, they're still green. They still photosynthesize. So they're still doing that basic chlorophyll stuff. But then they've supplemented their nutrient-poor diet in the soil with literally meat.
The little butterworts, they have a really weird carnivorous strategy where they don't have like a big tentacle, they don't have a big trapping mouth, they don't have a big external stomach. The animal steps on it, kind of pops these greasy little zits, essentially, and then it gradually kind of just encases whatever landed on it in a big bubble of death.
They're eating other animals, which is wild to think about. That a pitcher plant with that big stomach-like reservoir eats a frog, which is already kind of in the middle of the food chain.
As we were looking at the carnivorous plants, I was thinking about, I was trying to decide, like, how do I feel like this is different from a human digestive system? And I actually realized as I was explaining it, it's actually kind of hard to differentiate them. I mean, the more I've learned about the human digestive system, the fact is we basically have an open tube that runs all the way through us, and it makes a bunch of turns and stuff, but it's basically a giant water slide. And, you know, like the food that we eat doesn't necessarily come into contact with us. It just comes into contact with the edges of this tube, you know?
Right.
And so that's essentially what most of these plants are doing too. There's a tube, they make contact, they put digestive juices all over it, and the nutrients flow, you know, through into the plant. So that made sense to me, and I realized that it's actually not that different from how we eat things.
It's less of a journey.
Right.
That essentially a carnivorous plant goes from a mouth to a stomach all in one. That the Venus flytrap has that big gaping mouth with the little trigger hairs inside. So when those trigger hairs get stimulated by whatever actually crawls inside there, then as it gradually snaps closed, it kind of transitions from that mouth structure to a stomach structure. It even creates like a liquid seal around the surrounding outside of its lips, teeth, modified leaves, to have a airtight, watertight seal. So then at that point, it's not really a mouth anymore. It's now a digestive sac that it then floods with all those wonderful digestive enzymes.
It's absolutely terrifying. I can't imagine
And
feeling
it's
that.
so slow, which is
Yeah.
awful. It takes place like 15 days or something insane.
Right.
And then after it opens up, the husk of whatever it ate falls out, which then attracts more insects to like eat the corpse, and then it's ready to go all over again.
Wow.
I know, wild, but that's the Venus flytrap. That's not even the fun one.
Okay.
Okay, the really fun one, sundews.
Okay.
And this is my new favorite one, right there.
Okay.
These glistening little diamond bead ones.
Looks like dew.
Looks like dew, sundew, exactly. It's not dew.
It's pretty cool to think that these plants over time have learned to adapt in otherwise very nutrient-poor environments where their roots wouldn't be working as successfully in order to supplement their nitrogen, phosphorus requirements with flesh.
Right.
Those little tiny beadlets look like nectar. They smell really sweet, so it attracts caterpillars, it attracts flies, butterflies, wasps. However, they're really sticky, and they're actually made of a digestive substance. Sticky, gooey. You're a little
It
stronger
doesn't
than
feel like water, but you know, I can tell that there's something more there, for sure.
So the neat thing about the sundews...
Actually, that gets stickier as you kind
Ooh,
of.
yes, it does.
Yeah.
So the crazy part about these sundews is they actually start to curl in on themselves. So they're all splayed out. These little sticky goo drops at the end of each hair is a digestive substance. It's also kind of a hydraulic system where it starts to send electrical signals, move the water around, and gradually curls in on itself. So all of those little beads of doom, essentially, are able to make contact with whatever their prey, essentially.
I anticipate you being on my show forever, so
We're old growth at this point.
that's what we need to do. So make sure that you're
I'm not going anywhere.
all right. Good. Don't go anywhere. Obviously, if you are coming down to Florida, come down to Marie Selby Botanical Gardens. You'll have a great day here. It's a great place to go.